Hi, welcome back. In this video, we're going to talk about composition of transformations. So far, we've spoken about reflections, translations, and rotations. If you haven't seen any of these videos or are unfamiliar with reflections, translations, and rotations as transformations, you definitely want to get comfortable with these three different things, because today we're going to do a combination of any of these three things. So we're going to be able to do a reflection and a translation, reflection and rotation, or any other two combinations. So let's get to it. In this example, we have triangle XYZ, and we're going to translate along 1, 2, and reflect it over the y-axis. So the first thing we're going to want to do is we're going to do a horizontal shift of 1 and a vertical shift of 2. And we can do that here on the graph. I can plot it 1 to the right because it's positive and 2 up. 1 up 2. This is going to be my new x value. 1 to the right, up 2, my new y value. And then to the right, up 2, my new z value. This is the triangle after the translation. Now, you don't even have to use the graph if you want. Since they're both positive, you can add to the values. So x prime, you add 6 plus 1 is 7, and then 5 plus 2 is 7. If you look at y prime, you're going to add 1 value, which is 8, and then add 2. Negative 4 plus 2 is negative 2. Same thing with the value z. Horizontally, we're moving 5 and 1 to the right, so 5 plus 1 is 6, and negative 5 plus 2 is negative 3. You can do everything graphically or algebraically with strictly just the points. Once we've done that, our goal is to reflect it over the y-axis. So I'm going to use this as my line of reflection. Visually, I'm going to count how far away I am from the line. 1, 2, 3, 4, 5, 6, 7. I'm 7 spaces away, so I'm going to go 7 in the exact opposite way. 1, 2, 3, 4, 5, 6, 7. Again, hopefully this video is more of a review of everything that we've done so far. So if you're not feeling comfortable with compositions, feel free to go back and watch translations, reflections, or rotations, whichever one you're struggling with the most. With y prime, I'm going to move over 1, 2, 3, 4, 5, 6, 7, 8. So I do that in the exact opposite direction. 1, 2, 3, 4, 5, 6, 7, 8. This is my y double prime. And then for z, it's 1, 2, 3, 4, 5 away from the line. 1, 2, 3, 4, 5. This is my z. Sorry, I counted the wrong z. I'm looking at the z prime. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is what we're looking at. We are using the transformation from before. So x prime, y prime, and z prime. That'll give us the double prime. And if you look at the graph, let's see if I can do it in a different color for this one. This is the triangle, where it ends up after 2 transformations. Now, without the graph, if we look at our rules, when you're reflecting it over the y-axis, since you're flipping it over to this side, it's the x value that's going to change to the opposite. So if I already know the x value is 7, it'll be negative 7. Since the value is positive 8, we're going to flip it to the other side, negative 8, negative 2. And then for z prime, the positive 6 turns to a negative 6. And you can confirm that with the graph. So a composition is when you are doing a transformation composed of 2 or more transformations, 2 or more things that are happening to the original image. If you feel comfortable with this already, feel free to fast forward or skip a little bit more towards the end where I work with the problems backwards, where I do backwards composition of transformations. For this one here, I'm looking at translating it negative 1, 3, which means 1 to the left and 3 up. With the points, I can already do 6 minus 1, which is 5, and then 5 plus 3, which is positive 3. 5 plus 3 is 8. 7 minus 1 is 6, and negative 4 plus 3 is negative 1. For z prime, 5 minus 1 is 4, and negative 5 plus 3 is negative 2. All that means is that I'm moving it over 1 to the left, 1 to the left, and 1, 2, 3 up. I'll do this in red. 1 to the left, 1, 2, 3 up. 1 to the left, 1, 2, 3 up. Again, you can do this, all of them graphically or not. For double prime, we're rotating it about 90 degrees about the origin. We're going to assume this is counterclockwise. So the 90-degree rotation rule says we're going to switch the values and do the opposite of the first term. That's going to be the opposite of whatever we have for y. So I can switch the values here, 8, 5, and then make the first one opposite. Switch the terms, make the first one opposite. Switch the terms again, and make the opposite of the first one. And that's how you can graph it, or sorry, that's how you would find a 90-degree rotation. You're switching the x and y values, and then the opposite of the y value, which is now the x value. I'm not going to go ahead and graph that since we already have the points. Feel free to plot those points here, and you can see how it would rotate. For this one, we're rotating about the origin 180 degrees. The rule for 180-degree rotation is you're just going to do the opposite of x, opposite of y. So, if I already have both positive values, that means that this is going to turn into a negative 6 and a negative 5. For y, opposite of 7 is negative 7, and opposite of negative 4 is positive 4. And for z, opposite of 5 is negative 5, and opposite of negative 5 is positive 5. Now, opposite to a 180-degree shift would end up leaving us somewhere on this side, because they're on the exact opposite quadrant. Now, once I do a rotation, a rotation of 180, let's plot those points real quick. Negative 6, positive 5. This is x prime. When I do negative 7, 4, sorry, I'm missing something here with my rotation. 180 degrees, opposite, negative 7, 4, negative 5, 5. Yeah. There we go, that's the problem. I realized I was noticing, where is my problem here? The thing is, I was graphing negative 6, negative 5 wrong. So negative 6, and then down negative 5. This is where I have x prime. Negative 7, 4 would be up here. This is y prime. And then negative 5, 5 would be up here for z prime. There it is. Reflection over 180 degrees. So everything becomes opposite. Now, when I reflect it over the x-axis, this is what I'm going to reflect over the x-axis, which means I'm going to flip the bottom to the top, and the top values will be in the bottom. The only thing that's being changed here are the y values. So I'm going to keep the x values the same, and I'm going to do the opposite of y when I do a reflection. It's the y that's going to be flipped as the opposite. So the x value, x stays the same, the y value changes to opposite 5. Y double prime negative 7 stays the same, it's the opposite of 4. And z double prime, the x value stays the same, and it's the opposite of 5. And that's how you will end up landing on this last location. Now, so far we've been going forward in a composition of transformations. Now we want to undo it. We want to work backwards. You're given triangle A, B, and C. This should be A double prime. Let me change the color. I didn't label this correctly, but it's A double prime, C double prime, and B double prime. Which means this is where we're ending up. Our goal is to go backwards to the original points, A, B, and C. The original triangle was rotated 90 degrees and then reflected over the y equals x line. So to undo that, you have to do the most recent thing first. We're first going to reflect back over y equals x, which is this line. We're going to first reflect it over that, and then we're going to go 90 degrees counterclockwise. So whenever you're undoing a composition, you have to undo the most recent thing that landed you here. And then you undo the last thing, which was the first thing that got you there. So we're going to first undo the reflection over y equals x. Reflection over y equals x, all you really need to do is switch the y and the x values, because y becomes x and x becomes y. So we need to reflect it, which means this triangle will flip to this side. It'll end up landing on the second quadrant. So I can take the points. I can do A prime, B prime, and C prime. When I switch the values, this becomes -1, +2. For B, I get -4, +3. And for C, I get -2, +4. As I graph those, you'll see how -1, +2 is on the exact opposite side of that line. B prime is -4, 3. And then C prime is -2, 4. You can see how the triangle was reflected across that side. Now, what I want to do then is rotate it 90 degrees counterclockwise. So I'm going to take the image that I just got, I'm going to take this and I'm going to undo a rotation. Okay? So I'm going to undo a rotation counterclockwise, which means I applied the rule -y, x. This is the rule of 90-degree rotation. The original points are going to be x, y. What do we notice as a difference? Well, I notice that the x value stays the same. It's the y value that's going to be opposite. So to go backwards, I need to switch the points x, y so that they're in the correct order, and then the y value I have to do the opposite. So switch and opposite of y. So I take my points and I'm going to switch them first. A double prime becomes 2, -1, and I'm doing the opposite of y, which makes that a +1. For B double prime, I switch the values. I get 3, -4, and then I do the opposite of y. Same thing for C double prime. I switch the values, 4, -2, and then I make the opposite of that. And if you think about it a little bit, when you're undoing 90-degree rotation, that means that this came from this quadrant. What do we know about this quadrant completely on this first side? Is that everything in that quadrant, x is positive and y is positive. They're both positive values. Notice how my solutions, they're all positive values. So I know I ended up in the correct spot. I would recommend you do this one on your own. I would press pause and then try to undo this rotation of 180 degrees. and a reflection over the x-axis. Try to undo that with this given graph and see if you get where I get. Then feel free to press play and watch me solve the problem for you. So, to undo this, I need to first reflect it back over the x-axis, which means I'm going to flip all the points to the opposite side. This is going to be B. A is going to be 2 spaces below. D is going to be 3 spaces below. And C is going to be 2 spaces below. If I look at the points, when you reflect it over the x-axis, the only thing that's changing as you flip this over is the y value. X stays the same, it's y that becomes the opposite. So I can write the points as -1 stays the same, 2 becomes opposite. For B, -2 stays the same, -1 becomes the opposite. For C, -4 stays the same, 2 becomes opposite. For D, -2 stays the same, 3 becomes opposite. And notice how all the values here are negative and negative, which is true. Now I want to do a 180-degree rotation. Now, a 180-degree rotation means that I'm going to go back up here is 90 degrees if I'm undoing it. And then I'm going to do another 90 degrees, which gives me 180. So I'm looking for my answers to be over here where both the x and the y are both positive. So all I have to do in my 180-degree rotation is look at the rule. The rule is x comma y, -x, -y, takes me to x comma y. Notice that the only thing that changes is the signs. I have to do the opposite of x and the opposite of y. So a double prime becomes opposite of -1 and opposite of -2. B double prime, opposite of -2 and opposite of -1. C double prime, opposite of -4 and opposite of -2. And D double prime, opposite of -2 and opposite of -3. This is what we call composition of transformations because we're doing 2 or more things to our original shape. We're doing a translation and a rotation, a translation and a reflection, or a rotation and a reflection, right? A combination of those 3. Please let me know if you have any questions below. Let me know if you have any questions on working backwards with compositions or working forward. Don't forget to like and subscribe if you haven't already. And as always, we'll calculate later.